That was my intro music. I don't know why, I just feel like I wanted some today. Um, so, today we're continuing with our ESP32 Key Studio Smart Home Kit. And so if you see in the lower right corner, you see our smart home model that we built. And you see the revolving door. That was the last project that we did. We have the servo motor connected to that, and the door is rotating back and forth 180 degrees, which is good. That's what we want. And what are we doing today? Today we are using a project to close the window. So what we're talking about right here, as you see, over here we have a servo motor, and we have this window. And on the inside of the model, see, we have these mechanisms. And there's like a, see if I can do this. It's supposed to slide, you know? We have a sliding window. So we're going to do that. That's what we're doing today. Now, so we will use the servo and the raindrop sensor. Now, I'm not sure. This is a humidity temperature sensor, and this is a steam sensor. So I think we're going to be using the steam sensor. We'll find out eventually. But we want to use the raindrop sensor to make the device close the window when it's raining. And so the raindrop sensor is an analog input module. And the greater area covered by the water on the detection surface, so I think it's this one. The greater the surface area covered, the greater the value returned. So that's analog, whereas digital is 1 or a 0, right? So you can see on this one, it appears that we have a range between 0 and 4096. Not exactly sure what the significance of the number 4096 is, but you can tell it's not 0 and 1. It's a range between 0 and 4096. So here's our code. We will read through that in just a minute. And our test result says, at first, the window opens automatically. So that should be in the setup function. And when you touch the raindrop sensor with your hand, this would be probably in the loop function. When you touch the sensor with your hand, which has water on the skin, that's where we get our moisture sensor, the window will close. Okay, so let's take a quick look at our code. Where's my code? Here's my code. Okay, so first thing, we're going to include this ESP servo library. So let's just do that real quick and make sure we're here. Include library, and we want a zip library, and servo ESP32 servo.h. So this is the one we want. We'll select that. We've already installed this for the previous one, so it's asking us, do we want to overwrite it? No, we've already installed it, so there's no need. But if we hadn't, we would need to do that step. Gosh, all these pop-ups. Okay, now, our next step is to define, and we're going to call it servo pin on pin number 5. And then we're going to define water pin on pin 34. And if you guys remember last time, we created a servo object using that library from the class servo, and we changed it, or we named the variable myServo. This is the name of the object. It's from the class servo, and we named it myServo. So we instantiated myServo. So let's move on to our setup function. We have void, because we're not returning any type. We're not returning an integer or anything. We have our setup function, and inside we are establishing our serial communications, baud rate of 9600, We have our begin method, which is part of the serial class, right? We have our pin mode, water pin. This is our water pin up here. Is told to be an input, and that's the mode we're using. So this is a function. The pin mode is a function, and we overload it with the water pin, which is the hardware, and we call it an input. Now this is our class for our servo pulse width management, or pulse width modulation rather. So we have this class that we're pulling in, and we have an allocate timer method. Okay? So what does this tell us when we highlight it? Come on. Okay, this says it's a static method called allocate timer. And it doesn't return anything. You see it's void. And it has parameters are an integer timer number. So allocate timer. Add param a timer number 0 through 3, indicating which timer to allocate in this library switch to explicate allocation mode. What does that mean? I wish I could tell you. I've never heard the word explicate before, so that's kind of cool. But these are all overloaded with 0 through 3, you see? So let's figure out what that does. That's our pulse widths, right? And then we have my servo. That's our object that we instantiated right here. And in the servo class, there's a set period hertz. It's an instance method that we use on our instantiated servo called set period hertz. And that is loaded with an integer representing hertz. So that 50 means that we're moving everything at 50 hertz. And that's our standard for a servo, apparently. And we also have an attach method, right? Let's see what this means. It's another instance method that's applied to the myServo object that we instantiated. And it has 3 overloads, has 3 parameters. An integer with a pin number, an integer with a minimum, and an integer with the maximum, right? So, servo pin, this piece of hardware is on pin number 5. So we're going to attach servo pin on, I'm not sure if this is 100% accurate. We had this thing earlier, I thought this might be a 13. Attaches the servo on pin 18 to the servo object using default min-max 1000 and 2000. Different servos might require different min-max settings for a 0 to 180 sweep. And then we have a delay of 200 microseconds. One thing I want to do real quick, I want to take a half step over here and pardon me, I know this isn't going to be, let's see here. I need to look in here, and I've got another file open that I'm trying to, that's not the one I want. Okay. Let me see here. Let me bring this up so I can show you what I'm looking at. Okay. Index. And I'm going to get this one called index.pdf. We'll just say OK. So what I want to look at here real quick. Oops. Is we got to scroll down here. And we should be get all the way down here, all the way down here. It's going to be further down. Oh. this is the build that we did, and unfortunately, I was not using the YouTube page, so these builds are not on my YouTube page. Okay, so that's a temp and humidity sensor. It's installation diagram prototype. Temp and humidity sensor goes to IO17. Yellow LED module goes to IO12. Steam sensor goes to IO34. Is that what we're looking at? Yeah. So that's our steam sensor, goes to IO34. That's what we'll be using today. And we got to find our other servo. At least now we know. That's the right button, the RFID module, LCD display, RGB, it's a gas sensor, buzzer, servo controlling windows to IO5. And what do we have up here? That says servo pin 5, right? So servo controlling the doors goes to IO13. And that in and of itself is no problem, but when we looked at that door, and get rid of that now. When we had the door yesterday, we also had this note here. It says attaches to servo on pin 18 to the servo object. And I thought maybe that was 13 because the door servo was on pin 13. So I still don't know if this is a typo or if this is I'll have to look this up and see if I'm misunderstanding part of the instructions. But pin 18 on the servo object. We'll have to figure that out a little bit later. Let's continue. So we have our loop function, which returns nothing, it's void. And we declare an integer named water value, and we assign this analog read method. Is that it? That's a function, analog read function. It's not part of a class or an object. And the overload for that is water pin. So whatever this is saying, we're reading the value of water pin, which is going to be 34, and we're assigning that to the water value. Let me make sure I'm reading that right. Pin mode, water pin input. Okay. Then we're going to serial print line to the console, the serial console, the value of the water pin. So whatever this reads, it's going to get assigned to water value. It's going to get reassigned down here. And if the water value is greater than 1500, then we're going to write to the servo, my servo, the value of 0. And then we're going to delay. And else, meaning if the water value is not greater than 1500, we are going to write this number 176 to my servo. So these are probably this, that's probably going to be like all the way open. That's probably going to be closed or something like that. And then we have a delay of 200. So let's go ahead and run the code. Let's quit talking about it and run it. And let's see what happens. And we compile our sketch. We should see this start behaving some way. I'm trying to adjust my lighting there. Okay, so it looks like what's happened. Our door stopped moving. So it's telling us that our... I'm touching this with my bare finger. I don't have any moisture on here. But now I got a glass of ice water right next to me. And I'm just going to touch that. There we go. And you can see, as we touch this, our servo is closing. And like I said, I have a little bit of water on my finger. But let's try try a tiny bit. I should have gotten like a Q-tip or something. So I could put just a tiny bit of water on that. There you go. It's hard to wipe all that off and get just the right amount on it. And anyway, you see what we're doing is working. And we're just getting started, so we're not trying to do anything great here. But what I'm trying to see is, can I make it more, or can I put like a tiny amount on there and make it only go like part way or something like that, right? And that's why I think, in fact, let me grab a Q-tip. I wonder if I can, I should say a cotton swab. That way we're not using any brand names. Let's grab a cotton swab. I want to see if I can do like a little pinpoint. Huh. It's not feeling that. And I've dipped this cotton swab in water. We've seen it work with my finger. Come on, you jerk. Well, something about it. Let's wipe it off. Dry side. I'm not really doing much to get it to close like halfway in between. But we can tweak with that later. We don't. Right now we know that the thing works. We know that everything is pinned out. We know the code works. Now we can just make adjustments, you know. And so that's good. That's good. I'm gonna go ahead and stop here. But just to give you a quick preview, our next project is going to use the SK6812 RGB LED. So look forward to that in the next video.